So I took this question 1 right from your test, from the written section. It might be the first question on the written section. Don't quote me on that, though. I might have had to move it around to try and save paper. Anyways, I'll even be more specific then. You can bet that you're going to have on your test, probably a fairly easy one to crisscross and get the formula for. Then probably a nastier one, but it won't be multivalent yet. Then probably you're going to get some multivalent ones after a couple of questions. Probably this one is multivalent. I haven't looked it up on the periodic table, but I'll bet you it goes normal, 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 multivalent, multivalent, and then I bet you it goes polyatomic ions, and then I bet you it goes multivalent and polyatomic and the whole schmear. Okay? So if you can handle this, you're in good shape. Then on your test, I asked you to draw 1 or 2 board diagrams. On your quiz, I gave you a bunch for practice. What else is on your test? On the written section, I did ask you some questions about physical and chemical changes. So I'm going to give you a list of stuff, and I'm going to say, hey, is this a physical change or is this a chemical change? Key idea. How do you know that it's a chemical change? What's the question you ask yourself? Yep. Is something new produced? How do you know it's a physical change? Something new was not produced. Now, there's a couple of other questions that usually work. Usually, a physical change is reversible. So, for example, baking is a chemical change because it's tough to undo reverse baking and get back to the batter. But there are some obscure chemical changes that are reversible, and there are some physical changes that aren't reversible. So don't use it. The key question, was something new produced? All right. I've stalled long enough. Mark your quiz. Here we go. Anybody not have the quiz here, sheepishly can't find it? I'll damage your self-esteem, but I'd rather have you follow along. Got it? 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 Okay. Who's my favorite student? I am Mr. Dueck. Sorry. My favorite student is my friend. Uh-oh, is my pen going to work? This is going to be a problem if my pen doesn't work. Uh-oh, hang on. Let's pause the video and see if I can repair this. So, my favorite student, yay, my pen works. Good old. You know what? I'll introduce you to a new student of mine. Good old I'm a Chekhov. Okay, here we go. Think about it. No? Okay, tough audience. Oh, someone got it there. Lithium chloride, I'm pretty sure it's LiCl, because I think when I do the crisscross rule, lithium is a +1 and Cl is a -1. You can't go wrong with that. Yeah. You don't think I'm recording? Did I forget to unpause? No, I did. Nice try, but thank you for checking. It's a team effort. Okay, so Kevin Smarty Pants, how many atoms make up this particular compound? 2 would be right. Now, in terms of the way I'm going to mark this, it's probably going to be half mark for that, half mark for that, but you have to have the right subscripts. You can put a 1 there and a 1 there, although technically that's bad manners. You can, just like you can walk around with something hanging from your nose. There's no law against it, but if you want friends, deal with it. If you want to have science nerd friends, don't put the 1s there. Oh, and then 1 mark for that. SCBR, SC, oh boy, is that scandium? I was picking obscure elements on the quiz because I was having fun. On the periodic table, there'll be ones you're fairly familiar with, but come on a quiz, how can I not find some obscure ones I haven't used yet? So SC, scandium element 21 is, here's the key, is scandium multivalent? Then you know what? No crisscross. In fact, it's just going to be scandium bromide. Half mark, half mark. How many atoms make up scandium bromide molecules? Well, I should be careful, by the way. Technically, it's how many atoms make up scandium bromide ionic matrices, crystal lattices, but anyways, 4. Magnesium nitride. That's going to be magnesium, which I think is 2+. That's going to be nitrogen, which I think is 3-. I'm going from memory. Yell at me if I'm wrong. When I crisscross, okay, I'm going to get, for this to balance, for this to be stable, I need 3 magnesiums, and I need 2 nitrogens, because 2 nitrogens gives me a total of 6 negative, and 3 magnesiums gives me a total of 6 positive. Yep. How much are the number of atoms worth? Putting a 5 down, that gets you 1 whole mark. So, again, half mark, but if you don't have the subscripts right, you can't get the half mark. Okay? And again, do you see why this crisscross trick works? Hudson, what we're really saying is if each magnesium is -3, 2 of them, -6. If each nitrogen is -3, 2 of them make -6. If each magnesium is +2, 3 of them make +6. It's a quick way to guarantee that you have a total charge of 0, that all your negatives cancel out your positives. Oh, sorry though, you do have to reduce. Someone was asking me, Mr. Dueck, what's the crisscross rule? Really, I should call it a crisscross shortcut that usually works with a catch. You have to reduce. MgCl2. Well, first of all, I can do this part. There's 3 atoms. Mg, magnesium, multivalent or not? So no Roman numerals. This is going to be magnesium chloride. Next one. Ding, 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 ding. Iron is multivalent. It just got tougher, Kyle. Oh, no, wait a minute. When they give me the name in English, they actually tell me what charge they want me to use. So even though I could look it up, I know that iron, they want me to use a charge of 2+, even though it's multivalent. And bromine, I've kind of got memorized. I'm pretty sure that's minus. When I crisscross, I'm going to get 1 iron, 2 bromides, for a total of 3 atoms. Yeah. Ah! Nothing? I got over here, sorry. Wakey, wakey. Got you mid-yawn? Cobalt. Ding, 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 ding. Multivalent. So this is the toughest question. Going backwards from multivalent to name. I mean, it is going to be cobalt something. And Se, I think, is going to be selenide. I think it's selenium, right? Selenide. But I'm not done. It's multivalent. There's going to be a Roman numeral there. How do I figure out what the heck the Roman numeral is? That's a great question. I look here first. There's 1 selenium. What's the charge on 1 selenium? 2-. So I have to have a total charge of 2+. How many cobalts are there in this particular formula? Yep. There's 2 cobalts in this particular, there's a 2 right there? 1. So what's the charge on that 1 cobalt have to be? Has to be that. So it's cobalt 2 selenide. If you're missing the Roman numeral, you can't get the half mark for the cobalt.
Wait, so is it 1.5 marks on that?
No, no. Half mark, all or nothing? Half mark. Oh, and 2 atoms. Okay. Beryllium. Oh, not multivalent. That's kind of nice. Beryllium has a charge of 2+. Nitrate. That's not nitride. I got to look that one up. NO3-. Nitrate is NO3-. No, it's nitrite. I'm sorry, you're right. I read it wrong. Don't do that, what I just did. Nitrite. NO2-. Oh, this one crisscrosses then. It's going to be 1 beryllium, 2 of those, but I have to put it in brackets. So it's going to be NO2, 2. Right? How many atoms? Well, much like in math, you do what's inside the brackets first. There is sort of a bed mass to these It's not the same rule exactly, but close. Good hands, good catch. I got inside the brackets 2 oxygens, 1 nitrogen. 3 times 2 is, and 1 more is 7. 7. 7. 1, 2, 3, 4, 5, 6, 7. Yeah. Ich spreche ein bisschen Deutsch. My parents spoke German as their first language, so any of you have parents that speak a second language? Do they talk in front of you behind your back, and have you learned enough to understand so they can't talk in front of you behind your back? Right? I speak that much German. They can't get away with talking about me. SROH. SR, I think is strontium? I was picking obscure elements, Lena, having fun. Where the heck is SR? Strontium. Oh, element 38, not multivalent. So strontium has a charge of 2+. OH has a charge of -. I looked it up in the back. It's called hydroxide. So Roman numerals or no Roman numerals? No Roman numerals, not multivalent. This is going to be strontium hydroxide. How many atoms? 2 inside the brackets times 2, 4, 5. Lead 2, oh, wait a minute. No, going from English multivalent isn't bad. In fact, in some ways, it's easier, because what's the charge that they want me to put on this lead? Has to be. In fact, I don't even need to look it up. I think the symbol for lead is Pb. Have I told you why it's Pb and not L? Comes from the Latin word for plumbing, like for pipes. It's because they used to, in Rome, make the pipes out of lead, which is why they were so loopy. They all went, right, got brain damage. Anyways, moral of the story is don't drink lead. Speaking of, also don't drink cyanide. Cyanide, which is a surprisingly simple molecule for the poison, like, because cyanide poison is what the spies always swallow in the movies, or the villain always swallows, right? Surprisingly, a very simple molecule. It's the Canadian National Railway, CN minus. So it's going to be 1 Pb, 2 CNs, but to show that it's 2 of those, I better put it in brackets. And that gives me a total of, right? Is it 5? I did that one in my head, which I would never do on a test. On a test, I would count it carefully. The last one, IRPO 4. IR, what the heck? I was picking obscure ones. I think it's iridium, isn't it? I think I went a ways down in the where the heck is iridium? Oh yeah, element 77. I was moving. Oh, multivalent. Now this got tougher. How do I figure out? So it's going to be iridium something, and PO4 is phosphate. But the question, Nicole, is what's going to go here? What Roman numeral is going to go here? I look at this. First of all, how many phosphates are there here? 4 or 1? How many phosphate ions are there? 4 or 1? You're right, Jordan. 1. That 4 is on the oxygen, but it's 1 PO4. One of them. So when I look in the back, the charge on 1 PO4 is 3 negative. This whole thing, come here. This whole thing here has a charge of 3 negative. The total charge is 3 negative. For this to balance, what does the total positive charge have to be? Has to be 3 plus. How many iridiums do I have in this formula? Just 1. So it has to have, that 1 has to have a charge of 3 plus. And I have a total of 1, 4, again, 5 atoms. So you can give yourself a little score there out of 20, somewhere off in the margin if you want to. No marks for the crisscross rule. That's just there to help you. And I'll put that, I think, because I was initially doing everything off in the margin, I'll put that chart, that column in the middle on your test so you got a little scrap area to do the work in, okay? But don't freak out and think, oh, I'm supposed to write stuff there. Draw a board diagram of, how would I pronounce Li2O? What would I call that in English? Lithium what? Not oxygen. Lithium what? Oxide, right? This is lithium oxide. Okay. How many lithiums are there in this formula? 2. How many oxygens are there? 1. So here's how I'm going to draw this. Don't write this down if you didn't do that, but I'm going to do an oxygen in the middle, a lithium, and a lithium. I'm going to surround it like that, but I got to do a board diagram. But I got my setup. Okay. Blue is a good oxygen color. So I'll go blue. You don't have to go color-coded. So oxygen, yoink. How many protons?
8.
How many neutrons? Now I'm going to start to draw the shells. I know oxygen is on row 2, period 2, which means the first shell has its 2 electrons. The second shell has 1, 2, 3, 4, pair 5, pair 6. Now that's if it's an atom. However, it's not happy like that. What does it want to have? A full what? Full valence shell. That's probably a good vocabulary or question or multiple choice or fill in the blank word on your test. Hint, hint. Wants to have a full valence shell. How many more electrons does it need? It's going to get those 2 from the 2 lithium ions. Did I say ion? I'll tell you how I'm going to mark all this in a second, okay? Then I'm going to draw lithium. I'm going to draw the same thing twice. I'll do lithium in red. How many protons does lithium have? 3, you say? How many neutrons does it have? 4? Now, lithium is also in row 2, which means the inner shell is full. And now I'm going to make a mistake, so don't write this next part down. As an atom, it has that. It has 1 electron in its valence shell. It wants to get rid of that. So what it's done is it's gotten rid of that. In fact, that's that electron right there. So I don't draw the outer shell. The outer valence shell is empty. It's an ion. Did I say ion? Square brackets. Ion charge. And then you're going to draw exactly the same thing on the right. Copy. Paste. Then it sucks to be you. And oh, here, you know what? I'll make it look like I didn't copy it. There. Now it's a little bigger, so they'll think I drew it again. Yeah, trick. You guys thought I did all my notes by hand. Please. Something like that. So you ready? How many marks is this worth? 3? How many things did I draw? Oh, that works really, really well. So each of these is going to be worth 1. I'll tell you what I look for. What I actually do is I start out assuming you're going to get perfect, and I take marks off for mistakes. So how can you lose a half mark? If you're missing that, you lose a half mark, the ion charge. If you're missing the square brackets, you lose a half mark, the ion charge. If you have the wrong electron shell picture, you can lose a half mark. If you have the wrong nucleus, you can lose a half mark. Now, you can't go into the negatives, though. What I'm really saying is you have a total of 1 mark. If you make 2 mistakes, you're at 0. Sorry. The same for the next one, same for the next one. So the same idea. Start out saying, I get 1 mark for this, but lose a half if you miss that, or that, or that, or that. Start out with 1 mark for this, lose a half if you miss that, or you don't have the full valence shell, or you didn't do the nucleus. Same thing. Does that make sense? They should be worth more because they're lots of work. The problem, Riley, is I find kids struggle with these. If I make it worth more, it's also more marks that kids lose. So I make these worth 2 or 3, and I use a subtraction method of subtracting from mistakes. Okay? So if you're thinking, wait a minute, that's a lot of work for 2 marks or 3 marks. It is, but that's on purpose because I don't want to punish you if you can't get it. Does that make sense? Yeah. So you know what? For the people marking at home, I'll put a 0.5. A 0.5, a 0.5. Actually, I guess it's a minus 0.5 if you're missing any of those. Oh, over. Doesn't mean the quiz is over. It means turn the page over. NAF. No, it's not NAF. If I was a science nerd, how would I read NaF? What's that called? Sodium fluoride. Okay? Sodium multivalent? No, I won't give you a funky multivalent one to draw. Okay? I won't give you one to draw. I'll give you the chart on the previous page. I will not give you a because honestly, to be honest, Aiden, the multivalent ones, the electron things that I'm teaching you are wrong. The shells overlap and do weird stuff. And much like I've said, most of what I'm teaching you is garbage, but it works pretty good for the top 20 or so. No, I'll give you some more. I bet you I have another review quiz with physical and chemical changes and stuff on it too, which is not on this quiz at all. Right? 3.3, the whole physical chemical changes, you need to know that, right? Can I keep going now? Good, I'm gonna. Sodium. Oh, is there one of each? I'm just gonna do them side by side then. I don't need to put one in the middle. So sodium. Oh heck, I'll use black for sodium. Nucleus. How many? 11? Neutrons I don't have memorized. 12? Sodium is in row 3. So it has that full. And it has 1, 2, 3, 4, 5, 6, 7, 8. And now I'm going to make a mistake. If I said draw a Bohr atom, you would say sodium has 1 more. Don't draw that. Because sodium desperately wants to get rid of that electron. In fact, the further down you go in that row, the more desperately, fancy word, the more reactive they got. That's why I showed you the video. We saw cesium blew up in the water, like exploded the container, right? Remember that? So sodium is going to get rid of this electron. It gets rid of that shell. It's now an ion. Why is it an ion? 11 protons, 10 electrons. Did I say ion? Square brackets. Fluoride seems like a blue color to me. 9 protons, 10 neutrons. 2. Boy, that's terrible. I can do a better circle than that. Barely. Fluoride. Oh, you know what? Fluorine is only in row 2, so it's going to have 1, 2, 3, 4, 5, 6. That's how many electrons it has. If it was an atom, I would stop there. This is part of an ionic compound, so it's picking up the extra electron from sodium. Oh, did I say ion? Dan, another way to check if you're right. What is positive 1 plus negative 1 in your head? Nothing. What is positive 1 plus negative 2 plus positive 1? One of the checks is your charges should add to 0. That's what makes it a stable ion compound. Stable ionic compound. Okay, you know what? What's this out of? 3. How many things are there? So now it's 1.5 for each one. Subtract a half mark off for each thing you missed. So if you missed that, minus 0.5. If you missed that, minus 0.5. If you have the wrong electron pictures, minus 0.5. And if you have the wrong nucleus, minus 0.5. But don't go below 0. So you can make 2 mistakes and still get a half mark. Same for the fluoride. Next one. This is about as big as I'll ask you to draw. I won't go, because, by the way, like I could say, hey, draw cesium, which is just this huge, uber big board diagram. Lena, I'm going to assume if you can draw board diagrams of the first couple of rows, you could draw one way down. What a waste of paper, okay? Hey, how many what would I call this, MgCl2? How would I say that in English? I'll give you a hint. Magnesium chloride. Okay. I got to plan my attack first of all. How many magnesiums are there, Aiden? 1. How many chlorines are there? Okay, so I'm going to do a chlorine, a magnesium, and a I'm going to have it like that. That's my plan of attack. So I'll start in the middle and work my way out. So magnesium, heck, I'll use black for magnesium. What were you saying, Aiden? Protons is 12? And how many neutrons? Also 12? Yeah. Okay. Then, first row has 2. Second row has 1, 2, 3, 4, 5, 6, 7, 8. Now, if I was drawing the atom, this next bit is wrong, if I just said draw the atom, you would say, okay, it's got 1, 2 more. But this is an ion. It wants to get rid of those 2. Can it get rid of 2 electrons as easily as sodium can get rid of 1 electron? So what's more reactive, sodium or magnesium? Sodium. Okay? Hopefully you're starting to see how I went on the rant at the beginning of the year that all the action was with the electrons. It really does explain an awful, awful lot. It's an ion. Did I say ion? Chlorine. Yoink. 17 protons. 19 neutrons? 19, I think. You'd round to 36, take away 17, I think is 19. Mm-hmm. It's in row 3. Whew. 2. 8. And then normally chlorine has 1, 2, 3, 4, 5, 6, 7. It's going to take an extra electron from magnesium. And now it's an ion. And I'm going to draw exactly the same thing on the left. Jealous. Copy. Paste. Uh-oh. Undo. Paste. That looks a little big, Mr. Dueck. You're right. Why don't I shrink it down? No. No. In fact, hey, you know what? I'll even do this. There. Now they look really different. What did I make this one worth? 3 marks. You know what? Dan, this is your cue. What's -1 plus 2 plus -1? And again, what I'm trying to show you is, hey, there's a built-in error check there. Same as before, this time 1 mark for each one of them, half mark off for each thing that you missed. And then can you please give yourself a score out of, count them, 20, oh, whoops. Whoop. Let's go back. Out of, count them, 29, right at the top very clearly. So let's talk about your test Thursday. Part of it is multiple choice. I think there's about, I'm going from memory, 15 or 16 multiple choice itch questions. So to give you an idea of some of the ways I can ask you stuff as multiple choice, here is a little review quiz. You're going to have the remainder of class to work on this. This is what's due next class. And yes, Rihanna, I'll have a little video of me going through it, showing all my writing. It'll basically, whatever you see behind me will be what's in the video, okay? There's some easies, there's some nasties here, but you're also gonna see there is some physical chemical change stuff, because someone was asking, oh, is everything on quiz 2? That's the whole test? No, there is a little bit of matching, a little bit of terminology. Then short answer or written section here. Number 17 is more to get you thinking. I'm not wild about the way it's phrased. I'm going to let you try it, and you're going to hear me in the answer key. I think I went on a little bit of a rant saying this is if I asked how I would ask it. So I stole this from this. This is from the textbook. The textbook has sample quizzes, so I'll use their stuff. But I'm really nitpicky on how I word things, and this is not how I would word things. But anyways, write the formula, write the name. What's the difference between a physical change and a chemical change? Hopefully number 20 is like free marks, because I've done a rant several times about how do I know whether it's a physical change or a chemical change. Hopefully you know what the difference is. And there's your quiz. Let me pause.